Hello and welcome back to another video in which we are going to solve the past year paper from October-November 2019 pure mathematics 1, and the component is 1-3. So let's start. Here's the question number 1, first part. Expand 1 plus y raised to the power 6 in ascending powers of y as far as the term in y square. So we need to include till y square. So and we can see it is 1 plus y to the power 6, and if the first term is 1, then we can directly write it as, like, if I have 1 plus 1 plus x to the power n, 1 plus x to the power n, then it is 1 plus nc1 x, then nc2 x square plus, and so on. We can write nc3 x to the power 3 and so on. At the last we can write it as ncn and x to the power n. Here we can see it is power 6, so we can use Pascal triangles for the coefficient of this as well, and we are going to use in this way only. And it is 1 plus y raised to the power 6 would be 1 plus, this is 6c1, or the Pascal triangle values also the coefficient is 6, it is 6y, and the next one is 15y square. And we don't have to write the next term because it is like till the terms in y square, and it is in the ascending power of y. Here y power is 0, it is 1, here it is 2 here, so till here we'll write, and then we can write so on. Otherwise we can calculate 6c2 also through the calculator, we'll get the 15. So that's it. Let's do the second part of this. In the expansion of 1 plus px minus 2x square whole to the power 6, the coefficient of x square is 48. So in this case, first of all, we have to decide till what step we need to go. So we can see, we can rewrite it as 1 plus x common, it is p minus 2x, and then whole to the power 6. Now we can decide, if we are going to multiply any term by x square, then whatever there in the bracket, then it matters. If you are multiplying by x cube somewhere, so it means that it is going to be more than x square, so we don't require. So we are going to use this term here. It is y is x into p minus 2x, and we can write it as 1 plus 6 times x into p minus 2x plus 15 into y, that is x square into p minus 2x whole square. Now the next term will be like 20 into x cube. So when you are already multiplying by x cube, so any which way you are not going to get x square, so you'll stop here. Anyway, we can take the hint from this part that if they have asked till y square, so we need to go till y square only. And then it is 1 plus 6px minus 12x square, here it is 15x square, so 15x square into this whole bracket expansion, it would be p square, so 15p square x square, and then whatever we'll get, like to the second, a minus b square, p square, then 2x square, and then 2 times p into 2x, that would be x square, and you are already multiplying by x square, so that would be more than x square term, so you'll not write it, so only require to write till here. We can expand it as well. It's like going to be p square plus 4x square minus 4px, and if you are multiplying by x square, so only x square will get from here. So we can see from here the coefficient of x square, that is going to be minus 12 plus 15 p square is the coefficient of x square from here, and that is given as 48. So we can solve here, and it is 15p square is equal to 48 plus 12, it is 60, and then p square would be 4, that is p is going to be plus minus 2, but we can see, find the value of positive constant p, so it means it's given at p is positive constant, so we'll get p is equal to 2. That is the final answer. I hope it is clear. Let's do the second question. Here's the second question. The function g is defined by gx is equal to x square minus 6x plus 7 for x greater than 4. So the domain of gx here, it is given as x is greater than 4. So by first completing the square, find an expression for g inverse x and state the domain of G inverse. So first of all, we'll use the completing square method to rewrite it. So we can write G of x as, and we know for completing square method we only require these two terms, x square and x coefficient. And here we can see it is 1x square, so we don't have to take anything common. It is only depending on the x coefficient, that is minus 6. So it would be x minus 6 by 2, that is minus 3 whole square, and you always subtract the square of this term, that is 3. So it is 3 square and plus 7 as it is, which can be written as x minus 3 whole square minus 9 plus 7 is minus 2. So that is the gx. Now let's find the expression for G inverse. So we'll write it as y and then x to y and y to x. We will get it as x is equal to y minus 3 whole square minus 2, or from here we can write y minus 3 whole square is equal to x plus 2. I transferred this thing to this side and I have written like a is equal to b in this way, b is equal to a. And from here we get y minus 3 is equal to plus minus square root of x plus 2. We need to always be careful with the square and the square root with the plus minus, and from here we can write it as y is equal to 3 plus minus square root of x plus 2. And since it is going to be a function, we need to choose one of them, either plus or minus, and that depends on the, like, because we know it is going to be G inverse of x as 3 plus minus square root of x plus 2, and this gives the range of G inverse x, and we know that range of G inverse is same as the domain of gx, and domain of gx is given as x greater than 4. So it means this should be greater than 4. So in order to make this greater than 4, we have to take 3 plus square root of x plus 2, because if we take minus, then it would be 3 minus a positive quantity which will always be less than 3. So G inverse would be 3 plus root x plus 2. That's it. Now let's find the domain of G inverse, and one more thing we need to use, domain of G inverse is same as range of G, and range of G we can find from here. Like if we see this gx, this graph is like this, and the minimum point we get at x is equal to 3. At x equal to 3 we get the minimum point, and since the domain starts from greater than 4, so it means this is going to be the 4, and the range which we measure here on y-axis, we can see this range would be up more than that. So we require to get this point, and this point we will get it at x is equal to 4. So G of 4 will calculate, it is 1 square minus 2, that is minus 1. So this is the range. So range we'll write it like this, G of x, not like that, we can write G of x should be always greater than minus 1. So since range of G is greater than equal to greater than minus 1, so it means domain of G inverse would be x, for this x greater than minus 1. We should not write G inverse of x, because that would be representing as the range of G inverse. So we should always write the domain as the x is greater than something. So that's it they ask. I hope it is clear. Let's do the third question. Here's the question number 3. The equation of the curve of a curve is y is equal to x cubed plus x squared minus 8x plus 7. The curve has no stationary point in the interval a to b. find the least possible value of A and the greatest possible value of B. So for the stationary point, first thing we'll calculate what is dy over dx. That is a gradient function of it, which gives the gradient, and this is going to be from here 3x square plus 2x minus 8. And this we can see it is a graph, quadratic graph, and if we find the stationary point would be somewhere here, we can see this stationary point would be somewhere here at this point, and it is given between A and B. So we can take this, if we find these two values, which is of course the root of this quadratic curve, then we can say the least value of this least value will be this, and the maximum possible value, that is greatest value for this will be B would be this. And for that we need to solve the quadratic equation by making it equal to 0. 2x minus 8 equals 0, and we know it is 3, it's a 24, and 6 4s are 24, 6 minus 4 is 2, so we can take it as 3x square plus 6x minus 4x minus 8 equals 0. And first two terms we can take 3x common, it is x plus 2, and last two terms we can take 4 common, it is x plus 2 again. So from here we can write it as x plus 2 and x 3x minus 4 equals 0, means the root of the equation would be minus 2 and 4 over 3. From here the roots are minus 2 and 4 over 3. So it means these two values, that is this is minus 2 and this is 4 over 3. So we can write, and since this is like x in between A and B, so it means the A should be always more than this, A should always be more than this, and B should always be less than that value, that is 4 by 3. So the maximum of the least value, that is minimum of A would be minus 2 and maximum of B would be 4 over 3. So that's how we find the values where we have given that there is no stationary points. So sometimes question number 4. The diagram shows a semicircle ACB. It's a semicircle with center O and radius R. Arc OC is part of a circle with center A. So A is also a center of this arc. Express angle CAO, this angle in terms of pi. So we can see from here, since A is a center of this arc OC, it means OA is equal to AC, and since OA is R, so it would also be R, and moreover O is also a center for the semicircle ACB. It means OA is equal to OC. This, if we join this line, these 2 points, we'll get a line that would also be R because it's a radius. So in this way we can say that triangle CAO is an equilateral triangle, and all the angles of an equilateral triangles are going to be pi by 3. So it is pi by 3 CAO, sorry. And the second part is find the area of shaded region in the terms of r, pi and root 3, simplifying your answers. So we know that the shaded area we can find if we get the area of this triangle, which is of course 90-degree right angle triangle, because we know that in angle in a semicircle is always right angle. So this would be 90-degree, and we have this angle now, that is pi by 3, and this radius of course AO is equal to OA, that is R. So we can find the area of this triangle because we have the two sides, that is R and 2R, and angle between them. So we can find use the area sine rule for area. So area of shaded region would be the area of triangle minus area of sector. So let's do in this way. So area of triangle ACB is equal to half into first side, that is r, second side length 2r, and sine of the angle between these two, that is pi by 3. And we know that sine pi by 3 is root 3 by 2, that is going to be, these two get cancelled, and r into r square into root 3 by 2. That is the area of triangle. And area of sector, this sector would be 1 upon 2 r square theta. So 1 upon 2 r square into theta is pi by 3. So required area of shaded region would be this minus this, that is r square root 3 by 2 minus r square pi by 6, or we can take r square common, r square 2 also common, and we are left with root 3 minus pi by 3. Any step is okay, and that is going to be unit square here. So I hope it is clear. That's it for this video. We'll be discussing the next few questions in the next video. Till then, thank you so much.